Okay, good morning everyone. I just had my two classes from 9:15, so I just had my tea. Okay, so I am a little late. Um, okay, so I will share my screen. I'm audible, right? Am I audible? Anyone?
Yes, ma'am.
Okay. Okay, last class, what we did, yes, we did about your intake structures, right? So I told that I will give you some pictures from book so that you can write your definitions and some points. So I have taken the pictures. Just wait. Okay. Please take a screenshot of this. Please take a screenshot of this. Shemia, please mute your mic. Room number 101. Yeah. Okay. So please take a screenshot of this page. Okay. The important line I have already marked in the book. So the function of your intake structure, you can write it from here. Okay, so next you take the screenshots of the factors governing on the location of an intake. We have already discussed the points in our last class. So you can write the points from here. Take a screenshot. Next, take a screenshot of this. Okay, 5 points. If you write and if you remember, then it's fine. Okay, 5 to 6 points is fine. Take a screenshot. Then okay, so I have told you to write about any one type of your intake. So, simple submerged intake, you can write it down. Okay, so I have given you the this. You can write it from here if you cannot find it in Google. Any one type of your intake structure. So, simple submerged intake, you can write it from here. Take a screenshot. Okay, then we have one diagram of your simple submerged. There are two diagrams actually, but if you draw the first one, then it is fine. Okay, you draw the first diagram. Okay, and then take this part as a screenshot. Okay, so just don't keep it in your mobile like this. Okay, the screenshots. Someday it might get deleted also. So better if you write down the daily notes daily in your copy. So you today you write all this these points and the definition of intake structure in your copy. Okay, and then write about your the simple submerged intake. Okay, so you draw this diagram and you write it down briefly 3 4 lines about the submerged intake. Okay, last class we have learned about your intake. Okay, so intake, you have take the from the source what the water is taken, and it is discharged to a conduit. Okay, it is discharged to a conduit. So after that, what happens? We have learned that suppose the water is taken from a reservoir, so the reservoir is at a higher elevation. Okay, so from that elevation, the water it can automatically with the force of gravity, the water flows to your treatment plant. Okay, but suppose if the water is not at a higher elevation, so what should we put? Okay, so we should use a pump. In that case we should use a pump. So for pumps, just the points, okay, the points means where the pump is required, where it is used. If you remember those things and about the types of pump, then it is sufficient. Okay, because all these pumps is, I think you have learned in your hydraulic machines, turbines, pumps, all those things you have learned there. So here we won't be discussing much about your, we won't go in detail about pumps. So let's see the points. Okay, what it is written here. Just give me a minute. Just
हेलो। बात कर रहे क्या? दे रहे क्या मैम का बात को?
sorry, I just had a call from HOD. Okay. Okay. So what we are talking about? Okay. So let's see. Okay. So the first point here, it's written as your to lift the water at the source when the water cannot flow by gravity into the mains. Just now I told. Okay, So in case of a low level surface, so every time it is not like that the water will be taken from a higher elevation. Okay, so sometimes what happens, it is the water source is at a low level areas, or it is taken from an underground source. Okay, so in that case, your to lift the water from the source to the distribution mains, so we have to use a pump, because the water it cannot flow due to gravity. Next point is your to leave the water at the treatment plant if sufficient natural slope is not available as to cause gravitational flow between different units of the treatment plant. The same thing, okay? So if in the treatment plant, sufficient natural slope is not available. So if natural slope is not available, what will happen? The gravitational flow it cannot happen. So in order to to cause so that the water can be lifted, so the your pump it is used. Okay, next point is your to lift the water after the treatment so as to force the water into the distributing mains either directly or through a service reservoir. So it is told that so after the treatment is done, suppose the treatment plant is not located at a higher level, it is at a low level surface. So from the treatment to the distributing mains, okay, to the distribution system, to transfer the water, the pump should be used if the treatment plant it is not located at a higher elevation. So the last point is what? When the pressure in the distributing mains has to be increased or boosted at some intermediate points within the distribution system so as to enable the water reach up to the required height of 3 stories. Suppose in the distributing system or in the distributing mains, suppose the pressure it is not high, so what will happen? The water it cannot reach up to the G+3, G+4, G+5 buildings. Okay. So what happens? We use pumps. Okay, so that the water from the distributing mains it can the pressure it can be increased, and the water it can be transferred, or it can be distributed to the third story, fourth story, or fifth story, and so on. Okay, so in these 4 cases your pumps are required, the pumps are used. So let us see what are the different types of pumps used. Yeah, have you taken screenshot of this one? These 4 points you need to write it down. Take a screenshot if you have not taken. Okay, so now let's see what are the types of pumps. So your first point is your rotodynamic pumps. There are 2 types of pumps. Okay, one is your rotodynamic pumps, and the second one is your displacement pumps. So what is a rotodynamic pump? Rotodynamic pump it has a what? Let's see. It has a wheel or rotating element which rotates the water in a casing and thus imparting energy to the water. So this means that a rotodynamic pump it has a wheel type structure. It has a rotating structure or an element which after the water is it goes there, the water it is rotated. Okay, in the casing the water it is rotated, and the energy it is imparted to the water. Okay, so that is how a rotodynamic pump works. And 2 types of rotodynamic pumps are there. One is your centrifugal pump, and the other one is your axial flow pump. Okay, axial flow pump. Okay, then the next type is your displacement pump.
Ma'am,
Yes,
hello, ma'am.
yes.
What is casing?
Casing,
What is the meaning of casing?
casing means what? You see, when suppose a machine is there, okay, just suppose that you have a casing so that the water it does not go here and there. Okay, suppose a machine is suppose your pump is there, the machine it is working there, and a casing it is made there so that when the water enters your this rotating element. Okay, when the water it strikes the rotating element, the water it can so that the water it does not go here and there. Okay, it does not spread here and there. So a casing is made so that the water remains in that
Oh,
place. Okay, so that is a casing. I think you have
okay,
seen
ma'am.
this in your hydraulic machines, turbines. You have learned, no? Turbines, pumps in your third sem, fourth sem. I think you have seen what is a
Forgot, ma'am.
casing. If you see in your book, I think you can see what's a casing. Okay, in every machines we have a casing there. Okay, so axial.
Okay.
Uh, so centrifugal pump, and we have your axial flow pump. Then next one is your displacement pump. So a displacement pump, okay, it works, under a principle of what? It creates vacuum. Okay, it works on the principle of inducing vacuum. See here, a displacement pump works on the principle of mechanically inducing vacuum in the chamber, thereby drawing in a volume of water which is then mechanically displaced and forced out of the chamber. That means the main principle of a displacement pump is that it creates vacuum in the chamber, and it then draws the water, and then it mechanically it force out the water out of the chamber. Okay, it throws the water out of the chamber. So it is also having a two types of displacement pump. One is your reciprocating, and the other one is your rotary type of pump. So this names you remember, no need to go in details. Just remember two types of pumps are there: rotodynamic pumps and displacement pumps. What are the types of rotodynamic pumps? Centrifugal and axial flow. What are the displacement the pumps? Types of displacement pumps: reciprocating pump and the rotary type of pump. Okay. So remember this much. You take a screenshot. Okay. So you have taken a screenshot. So pumps about this much only. You just write down in your copy. Okay. So next, we will learn about your characteristics of water. Okay. So we will learn about your characteristics of water. See, characteristics of water actually, uh, in order to ensure good health, so that people can have good health, and for economy purpose, for all those things, for aesthetic point of view also, the water it has certain characteristics. Okay, and those characteristics it should be measured before you supply the water to the public. Okay, after you take the raw water it should be treated on basis of certain characteristics. Okay, so those characteristics we should know, and those characteristics are of three types. First, the characteristics are of three types: physical, chemical, and microscopical characteristics. Microscopical, or you can see biological characteristics. So basically there are three characteristics of water: physical, chemical, and microscopical, or bacteriological or biological. Okay, same thing. That means of bacteria. So first we will learn about your physical characteristics. Physical characteristics we will learn. So I will just mark the lines, okay, which are important, and you can write those lines in your notes. Okay, you can make a notes by yourself. I will just mark the main points. So first point is turbidity. Okay, so under your physical characteristics we have turbidity, color, taste or odor, temperature, and specific conductivity. Okay, these are the points. These are included under your physical characteristics, and we will learn about this. Okay, so physical characteristics means I think everyone knows that you can physical. Okay, that is physical. You can see with your naked eyes. You can taste. Okay, you can touch. All those things are physical. So physical characteristics, under your physical characteristics, the first one we have is your turbidity. So what is turbidity? Suppose in a glass of water, okay, in a glass of distilled water, you are mixing some sand. Okay, some sand you are mixing. So obviously after if you keep that water still like that for 24 hours, the water, the sand, it will deposited at the at below. But if you stir it, if you again stir it, if you mix the sand and if you stir it properly, then you will see that the color of the distilled water, that is colorless, it will become somewhat, the water will appear to be something muddy or some brown in color. Yes, because you can see those things with your naked eyes. Okay, so that is clearly visible. You can see that, oh yes, the now the color, now the water, it is mixed with something. The color, the water, it is not clear water. Okay, so that thing is known as your turbid water. When the water, it is mixed with some suspended matter, like you can say clay, sealed, sand, all those things. Okay, when it is mixed with suspended matter, and also if some vegetations are there, some aquatic plants are present in that water. So all these things, this creates the water to look like muddy, or you can say cloudy, or in engineering term you will call that water to be turbid water. Okay, so you see this line, first line you write down, later you write down, I'll just take a screenshot. Okay, or later you can see the video also, it is uploaded, no? So this line, if a large amount of suspended matter such as clay, silt, or some other finely divided organic materials are present in water, it will appear to be muddy or cloudy or turbid in appearance. Okay, so the turbid water of the turbid water, if you drink that water also, that what, it will not cause harm to you. Okay, it will not cause harm to you, but will you drink the turbid water? Obviously no. Yes, because if you see water, it is something turbid, the water, it is, it is mixed with something sand and all those things. Obviously you will not drink that water. So we should, in every water, some, in all water, something is, something is there, but we should treat the water, and it should be decreased to a certain limit. Okay, there are some permissible limits up to which you can drink that water. So government, that they have already given the permissible limit up to which you can drink that turbid water. Okay, so you see here, the turbidity, it can be measured here, this point. Okay, the turbidity, it can be measured by a turbidity rod or a turbidity meter with optical observations, and is expressed as the amount of suspended matter in milligram per liter or ppm. That means the turbidity, it should be measured, as I already told. So it should be measured, and the it is done by using a turbidity rod. Turbidity rod is used in practical fields. Okay, in practical fields, you use turbidity rod, and for experiments in a laboratory you use a turbidimeter. Okay, and the unit, what the turbidity, it is measured in milligram per liter. You see, I will write here one thing. 1 milligram per liter is equal to 1 ppm. So what is ppm? Parts per million. Okay, so if I say that this sample of water is having 2 ppm of turbidity. That means this sample of water is having 2 milligram per liter of your turbidity. Understood, everyone? One, that means 1 milligram per liter and parts per million are same thing. Okay, so you should know this term. What is ppm? Somebody might tell you that this is the ppm, 2 ppm of turbidity is present in water. Then you should know that he means that 2 milligram of turbidity is present in that water. Okay, so there is a certain scale, like for measuring your turbidity, a scale is used, and that scale is your silica scale. Okay, just wait. Mm, you see this line? The standard unit is that which is produced by 1 milligram of finely divided silica in 1 liter of distilled water. That means if somebody says you that this sample it is containing 2 ppm of turbidity, that means that sample of water in 1 liter of distilled water, 1 2 milligram of silica is present. Okay, listen to me properly once again. If someone says you that in a sample, this is your sample of water I am giving you, and it is having 2 ppm or 2 milligram per liter of turbidity, that means in 1 liter of distilled water 2 milligram of silica is present in that sample. Okay, so that is your silica scale. Okay, that is your silica scale. So turbidity is measured in terms of silica scale. Okay, just remember this line. Next is your uh, a permissible limit. Yes, I was talking about permissible limit. So the it is written here, you see, a permissible limit of 5 to 10 units of turbidity for drinking waters. Okay, so you can write in your own sentence that the permissible limit for turbidity is 5 to 10 milligram per liter. Okay, it is written by units, but you can write it down. 5 to 10 milligram per liter is your permissible limit for turbidity. Okay, so next let's see. So this is your turbidity rod. See, this diagram is your turbidity rod that I was telling to you, and it is used in your what practical fields. Okay, it is used in the practical field. So how it is done is that you see here it is a eye mark is here. Okay, this is your eye mark. Okay, this point you have some eye marks here. This is a graduated tape. Okay, which is a non-stretchable one. Okay, it is not stretchable. This is a this is a aluminum rod. This whole part is a aluminum rod. This is a nickel ring. This part is a nickel ring. Then there is a platinum needle here. This part it is a needle of 1 mm dia and the length is 25 mm. So how it is done? Suppose you are taking a beaker, okay, with suppose water. What's happening? Suppose you have taken one beaker here or the sample of water, and you dip your turbidity rod in that sample. Okay, so you have your eye mark here. You have the eye mark here. So you put your eye here. You see, and you will be able to see your. You try to see your this needle. Okay, you will be able to see your needle. So you just keep on dipping the rod to your sample of water. You because and that sample of water is turbid. Okay, a turbid water you take, and then you dip your turbidity rod up to when you are seeing this needle, and one point of time will come when this needle it will become disappear. It will disappear because the water is turbid. Okay, so at that point of time when you are not able to see this needle, platinum needle, you stop at that point. You don't deepen it further. Okay, and you see the graduation mark. There will be some volume of water will be there, so you see the graduation mark, and that will be your turbidity. That much turbid of water it is present in that water. Okay, so like that, with using this turbidity rod you can see how much of turbidity is present in your water sample. So turbidity rods are used in your practical field, so where large amount of waters are used and all. When a large surface of source of supply is a very large one. So in practical laboratory we use turbidity meters. So turbidity meters we will see. So you see we have turbidity meters. You just write down there are three types of turbidity meters. Okay, there are three types. Number one type is your Jackson's turbidity meter. Jackson's turbidity meter. Remember the name and the range for which it is used. Okay, so for your Jackson's turbidity meter, your range of turbidity is your 25 to 1000 milligram per liter. That means if a water sample, raw water sample, it has a turbidity range between 25 to 1000 milligram per liter, then your Jackson's turbidity meter it is used. Okay, this much you remember. Okay, then next we have your Bailey's turbidimeter. Okay, we have Bailey's turbidimeter. You write down the range of turbidity as 0 to 10 milligram per liter. Then the third one we have one nephilometric. Third one we have is your Nephilometric turbidity unit, or you can say this is the unit, but the name of the turbidity rod is your name is turbidity meter is the name is your nephilometer. Okay, the name is nephilometer. Nephilometer is the name of the turbidity meter, and the unit for nephilometer is your this one, NTU. NTU.
Ma'am, screen is not clear.
It is not visible. Just wait. Shall I make it zoom? Shall I make it zoom? Now is it visible? Is it visible now? Yes. Okay. Yes. So you see, nephilometer is the name of the turbidity meter. Okay, number 3, and the unit for your nephilometer is your NTU. NTU, the full form is Nephilometric Turbidity Unit. Nephilometric Turbidity Unit. And sometimes this NTU is also referred to as FTU. FTU, which is the full form is Formazin Turbidity Unit. Okay, we have learned that turbidity, the scale of turbidity is your what? Silica scale. But sometimes in place of silica, one polymer named as formazine polymer is used. In that case, when formazine polymer is used, in that case your turbidity, it is the unit for turbidity, it is known as your FTU, which is your formazine turbidity unit. Okay, so this much you remember about turbidity. Clear? Now, next is your color. Next is your color. Okay, so color, you see, color, you what does color happen? Okay, why color happens? You see here, dissolved organic matter from here you see. Okay, dissolved organic matter from decaying vegetation or some inorganic material such as colored soils, etc., may impart color to the water. So dissolved organic matter, if it is present from decaying vegetations and all, and sometimes colored soils are also present. So all those things, it imparts color to the water. And sometimes excessive growth of algae and you can say aquatic microorganisms in the water, that may also impart color to your water. So you basically, if you see a colored water, something greenish color or bluish color, obviously you won't drink that water. Okay, but and also you cannot use that water for your personal use also. Like if you wash clothes in that colored water, the obviously your color, the color, it will be transferred to your clothes and the clothes will become dirty. Okay, so colored water generally people don't use, and we should try to measure. We have to measure the color. Okay, so how will we measure? Okay, turbidity, we had a turbidity meter, we have turbidity meter, and using that turbidity rod or turbidity meter, we used to measure your turbidity. For color also we have one thing. See, we have one tube named as Nessler's tube. Okay, in that Nessler's tube, your some standard colors are already present in that tube. Okay, some standard color intensity, some standard colors like green, yellow, blue, some colors are already present, and those are standard colors. Those are already present in that tube. Now you have a raw sample with you, which is a colored sample. Now what you do, you compare your color, okay, of your sample. You compare the color with the Nessler's tube. So what color it is, it matches. So that means that amount of color it is present in that water. Okay, so there it is written that this is for 1 ppm color is this much, 2 ppm color is this much. Okay, so that is a standard one, it is already given. So if your sample color and that Nessler's tube color it is matched, then you can find out that yes, it is written there that it is 1 ppm, it is 2 ppm. So you can measure like that. Okay, and for for accurate or precise determination of your color, there is one apparatus named as tintometer. You see this one? There is one apparatus named as tintometer. Okay, this is for your precise determination of small color intensities. You can use tintometer as your apparatus. And what is the maximum permissible color, permissible limit for your color for domestic supplies is 20 ppm. 20 ppm is the permissible limit for the domestic purpose. Okay, plus your 20 ppm it is given by already it is given. And also one more thing, like we have learned in turbidity that silica scale is used for your color, your platinum cobalt is used. Okay, you can write down this line later. Okay, the standard unit of color is that which is produced by 1 milligram of platinum cobalt dissolved in 1 liter of distilled water. Same line like turbidity, but here instead of silica scale we use your platinum cobalt scale. Okay, just remember like this. So this is all about your color. Okay. Okay. One more line is you can write it down is that for public supplies, the color number on cobalt scale should not exceed 20 and should preferably be less than 10. Okay. So you can write about this. Okay. So it's already 12 to 5 minutes to 11. Okay. So let's stop here today. Let me quickly take your attendance. Roll number 69, Jojo. Roll number 51, Bhuneshwar Shah. Roll number 52, 53, 54, 55, 56, 57, 58, 59, 60, 60, 61.
Present, ma'am.
Okay, 62, 63, 64.
Yes, ma'am.
Roll number what? 63.
Yes, ma'am.
Okay. 64, 65, 66,
Yes, ma'am.
67,
Present, ma'am.
68,
Present, ma'am.
69, 70,
Present, ma'am. 70%.
okay, 71,
Present.
72,
Present, ma'am.
okay, 73,
Present, ma'am.
74, Walusen, not present, 74 present. You open the chat box also. 74, if you present, just mark yes, give yes. Present, okay, okay. 75,
Present, ma'am.
76,
Present, ma'am.
77,
Present, ma'am.
78,
Yes, ma'am. 78.
okay, 79, 80, 81, 82,
Present, ma'am. 82.
okay, 83,
Present, ma'am. 83.
okay, 84,
Present, ma'am.
85,
Yes, ma'am.
86,
Present, ma'am.
86 likha, present, okay, 87, 88,
Yes, ma'am. 88 present.
89, 90,
Present, ma'am.
91, 92,
Present, ma'am.
92. Okay.
Present, ma'am.
93,
Yes, ma'am.
94,
Present, ma'am.
95, 96, 97,
Present, ma'am.
97 present, 98,
Present, ma'am.
99, 100,
Yes, ma'am.
100 present, okay. 101,
Yes, ma'am.
Present, ma'am.
102,
Present, ma'am.
103,
Present, ma'am.
104, 105,
Yes, ma'am.
106,
Present, ma'am.
107, Madhuspita, 108, 109,